Um, okay. Yeah. Hey everyone, I'm Arvind. Yeah, so I'll just make some comments about this year's or to this weekend's silver contest. Yeah, so there's three problems. I think for me personally, like I think problem three was the easiest for me. Or it's like more standard. It's like similar to other problems that show up. Problem one was also like kind of pretty doable. And then problem two is like quite implementation heavy. Yeah, I'm not sure how others felt, if they felt similar or different about this. Yeah, but this is how I found the contest. Yeah, and then we'll see more about the problems as I like talk about them. Yeah, so problem one is kind of like a greedy constructive problem. Yeah, and then two is like a very implementation heavy. Yeah, and then three can be done with like very nicely if you use two pointers. Um, yeah, personally, yeah, I think three was a pretty nice problem. Yeah, cool. Um, yeah, let's go into the contest, right? So this is the yeah, so I took the contest this weekend. Yeah. Um, right, this is yeah, this is silver, right? Yeah, so I think general good contest strategy is just to like read all the problems in the beginning, like yeah, and it's like know what the subtasks are. Yeah. Uh, like for example, like it seems like you can get most of the points in this problem by doing three subtasks. Yeah. Uh, I think yeah, also here the subtasks are pretty generous, like C equals 1, C equals 2. Um, yeah, and then yeah, you can get like roughly half of the points with these subtasks. Yeah, so I think yeah, a good contest strategy is to like just read all the problems. Yeah, so I think when I looked at the contest, I read this and then I thought seemed pretty cursed, so I just moved on to the other ones. Yeah, yeah, I think I did problem three first, actually. Yeah, and then I did one. I think I read two and I kind of had an idea, but yeah, I decided to do one before because it's more clean. Yeah, so let's start with problem one. Yeah, so basically, like, there's a bunch of cows in a line. Uh, yeah, and then Farmer Noge's cows, they tell lies, and then Farmer John's cows, they tell the truth. Um, and then like each of them has to tell like which type of cow is to their left and which type of cow is to their right. And you're given these sequences, but the catch here is that it's like permuted, right? So it's not necessarily the case, if I zoom in, it's not necessarily the case that this cow over here sits to the right of this cow over here, right? They're just like permuted in some weird order, right? But yeah, if you draw things out, you can make like some pretty like some observations that simplify things a lot, right? So let's just like look at the cases, right? So if there's two cows that are standing next to each other, both of these are Farmer John's cows, then the one on the right will say that the one on the left is J, and then the one on the left will say that the one on the right is J, right? So this is the first case if the two cows sitting next to each other are both Farmer John's cows. And then another case is both of these cows are Farmer Noge's cows. Yeah, so there's two N's. And both of them lie, right? So this one will say the one to the left is Farmer John's, and then this one will say the one to the right is Farmer John's, right? So it's kind of like the same pattern you see here and here. And let's just look at the other two cases, right? So Farmer John's cow is on the left, and then Farmer Noge's cow is on the right. Uh, then this cow will tell the truth and say Noge. Sorry, I flipped it. Yeah, this cow will tell the truth and then say Noge is on the right. And then this cow will lie and then say that John is on the left, right? Sorry, no, this cow will lie and say that Noge is on the left, right? And then let's look at the last case where Noge's cow is to the left of John's cow, right? Um, so this cow will lie and say that Noge is to the right, and then this cow it will lie, it will tell the truth and then say that Noge is to the left, right? So we can kind of see a pattern here, right? So when they're when they're the same, when they're equal, then both of these will say John. And then when they're different, sorry, yeah, and then the same here, they're both equal, so they both say John. And in these two cases, the left cow and the right cow are different, right? So the right cow says Noj is on the left, and left cow says Noj is on the right, right? So let's just consider like putting them in the right order, right? Then they'll form this kind of pattern, right? So um, like if these are your cows, whenever a change occurs, like maybe there will be a bunch of J's for some time, and then the next cow will become a Noj, right? And then there will be some Nojes from some time, right? So what these two strings will be if you like rearrange them, I'll just put another color. They'll look like uh uh N over here, and then N over here, and then J so here, and then J's over here, right? Right. So more generally, like we can kind of visualize it like this. So there's node over here, there's a node over here. This happens when the cow changes, and then maybe later again, the cow will change. So there'll be a node over here and a node over here. And then maybe the cow will change again later. So there'll be node over here and then node over here, right? And then in between, like they're all going to be Johns, right? And then these are all going to be Johns. This could be possibly empty, possibly empty. Uh, like for example, you can have a bunch of ends here, and then a node here, right? Um, yeah, and then you have a bunch of Johns in the middle, bunch of Johns in the middle, right? Yeah, so these node things could be like next to each other also, right? Yeah, so this is kind of like what the structure looks like. Yeah, and then there's like some, yeah, so you can already like rule out certain cases where the answer is no, right? So like a necessary case condition has to be like the number of nodes on top has to equal the number of nodes on the bottom, right? Otherwise, you can kind of rule it out. Yeah, and another necessary case is uh, if you like consider looping through the cows, right? Um, so just consider like the output is like NJ, right? So the number of times that a change occurs is always going to be even, right? So if we start from N, there's going to be a change when we get to J, and then a change when we get to N, and then change when we get to J. We're always going to get back to N when we cycle, right? So the total number of changes is going to be even, right? So also in this case, like if we start from this J, um, it changes to N over here, and then it changes back to J over here, right? So that like after each change, the characters are going to flip. If you start at J, it'll be from J to NJ until it finally ends at J, right? So the number of changes should be even, and we already know from here, whenever a change occurs, both of them have to be N, right? So another necessary condition, so I guess some necessary conditions uh, is like number of J on the top has to equal the number of, sorry, number of N on the top. Yeah, so the number of N on the top has to equal the number of N on the bottom. Yeah, and then another necessary condition is like number of N on the top has to be even because like if you go in a cycle, you're going to get back to where you started from. So the total number of flips will be even. So the number of N on the top is even, right? These are just some necessary conditions, right? And now I'll share the idea for how to actually like rearrange the thing to be in the desired form, right? Yeah, so notice like in the input, you kind of have like four kinds of things, right? So, yeah, so like you kind of have four kinds of things at each index. Either there's like JN, or there's like JJ, or there's NN, or there's NJ, right? Yeah, so one way you can kind of rearrange it to get it to work out is like we kind of want to kind of care like so if there's no NNs, like if there's no N like one directly on top of each other, then we can just do NN over here. We can just like place them arbitrarily, like and another NN over here, and then another NN over here, and we can just put J's in the middle, right? Something like this. right? But like it's also possible for n to be on top of n. So we can't have a case like this. But how you can get around that is just group all the n's together. So it'll look like this. We'll have a block of things where n is always on top of n, right? So this will be our block. Um, and then we know that we're required to have an n over here just because of the structure. Like n has to be the top right, and then n has to be the bottom left whenever it occurs. So this n is forced, and then this n is forced. Let's say there's a j, and then let's say there's a j, right? And then the rest of the n's, you can just arrange them like put n and n over here, right? And then put another n and n over here. And you can make these all j's, right? Yeah, I'll just put the n's in boxes, right? Um, yeah, yeah. So another condition that you have to check is that so if you just look at this, yeah, and then the rest of them are equal to j, right? So if you just look at this, like condition you can see is uh yeah, so the count of the things where n is on top of j is the same as the count of the things where j is on top of n, right? Yeah, so this is another necessary condition that you need. But yeah, yeah. Basically, if there is something in the input where n is on top of n in the input, then you can arrange it like this, and then put this n over here, put this n over here, and then keep repeating n. And that works. Yeah, and then the other case is where you never have n on top of n in the input, so you can just do n, and then just put j's over here. So wherever n's occur, you can just do this. Yeah, and you still have this necessary condition where the number of n's on top of j is equal to the number of j on top of n, right? So something like this is, hold up. Uh, yeah, this should be nj, so nj. And then you can just like fill the rest of them with j's, right? Yeah. Any questions? I'll summarize this. Yeah, so I think the most important part when you're like doing this problem is, yeah, try to yeah, like actually look at what they guess when they're next to each other. Like I think yeah, like basically how I came up with the solution is I had to look at, like when two cows are standing next to each other, what kinds of things will they reply, or will they say, right? And then we can notice that when the two cows are different, they'll say n, um, where it'll correspond to these indices in the input, right? And then when they're different, then they'll both say JJ, right? And then it remains to find a construction, right? And then a construction is just consider all the things where n is on top of n, just put them together, and then this n is forced, this n is forced, and then just keep making these diagonal n's, right? And then if there's none of these vertical ones, then just make a bunch of these diagonal n's, right? Yeah, any questions? Yeah, I actually haven't looked at what are the subtasks for this problem. Oh, I guess like, yeah, C equals 1 means you have to output it. C equals 0 means you don't. Uh, could you move the alternating ones to the end? Oh, like to the end of the string? Um, yeah, I think that can work. Yeah, I think it doesn't matter. It doesn't matter too much like where you place these. Yeah, so if you want, you could have, let me change the color. If you want, you could have like the block of ends over here, and then and then you could just like fill. So these have to be J. You can just like fill these with J's. Yeah, so I don't think this really matters. And then you can put N, these alternating ones here. Yeah, so something like this can also work. Yeah, I think I was like in an Uber when I was doing this problem. Yeah, and then yeah, I just remember like yeah, I think problem one and problem three were kind of fun, and then problem two was a bit cursed. Okay, any other questions?